Welcome everyone on my talk, which is being titled Enums on Steroids. However, this title is a little bit a teaser, as you will see later on, because it focuses rather on something I can somehow sum up as a syntactic sugar in modern JDKs. When I'm talking about modern JDKs, I have on my mind something which is from 11 to 21, because I think that 21 is now the stable version and it's being widely used as it was being somehow surveyed on the previous talk by Venkat and Josh. Almost half of the audience was using Java 21, so it makes no sense to just limit ourselves to Java 17. However, the inventions that I will be presenting would be done in non-linear way, because it's much more easy to present them feature by feature and not chronologically. But we will talk about it a few minutes later on. As during all these talks, it's better to start with my presentation. So my name is MARCIN CHROST. I came here from Poland for a few days. I'm an IT trainer and consultant, a freelancer, and I work mostly for two companies in Poland, Bottega IT Minds and Sages, and also I have mine own website. When you get all my contact information to me, if you would get some questions after the session, just drop me a note, just drop me an email. I will be also running around here for the next 2 days, so feel free to get me and ask me a few questions if you are interested. Okay, just not to waste too much time on me, because let's directly dive into the code and to the Java features. Let's start from a business case, because usually it's easier to talk about the language features when we have some real case that we can somehow discuss on and introduce the features one by one. And I had a lot of problems which business case I should choose for the talk. And then I just go some light bulb, like from the Eureka, something like that. And I said, okay, the inflation during the recent years has risen sharply. The inflation costs, the living costs are soaring, and unfortunately, everything is going up except our incomes. So, more or less, we will be needing, finally, we will come across the situations that we will need some extra money, and how you can get extra money, either by taking overtime, or just, there is the more simple way, just to get some loan. And this is exactly the business scenario I would like to talk about. So let's imagine that we have some small booth in a mall when you can just come from just across the street and apply for a loan. And this booth is just the input-output processor. And if you just apply for a loan, you are the loan requester. You state for the amount of money you want to borrow and the period of the loan what you are declaring to somehow repay it. We will not focus on the number of installments, also the rates. It's out of the scope of our talk. However, let's just focus on simple input and output. So the input is very simple. You need the amount of money for some given period. Okay, fine. Then we have this engine, the evaluator, which somehow evaluates these input conditions and decides what would be the outcome. And as you can see, there are possible 3 final responses. Not 2, because with 2 it would be too easy to model it, because just the plain old Boolean would solve the problem. And it's not so easy, sorry. So let's decide. We have 3 possible outcomes. So the first simplest one is that the loan application has been approved. But to somehow complicate this, let's assume that even approval does not mean that you will get all the money that you have requested. Probably the amount would be a little bit lower because according to some extra circumstances that is being taken by the evaluator, they may decide, okay, we will borrow you this money, but for example, 80% of that you have requested. Sorry. This is the first one. The second possible outcome is also a simple one. It's just the pure refusal. Okay, sorry, we cannot borrow you we cannot lend you the money, but just for the sake of being politeness and also to not get rid of this potential customer, we need to state what was the official reason why you cannot get the money from our bank or something like that. Okay, so I said that 2 outcomes were too simple, so let's add the third one. And the third one is something that is, how to say, it's intermediate between the approval and refusal. So we conditionally approve this loan request. However, we say, now, okay, but to get this loan, you need to provide us additional information. Usually it's an employee reference or something like that. And we set up you a deadline to meet these requirements. If not, sorry, go to this case number 2, pure refusal. Okay, summing it up, it appears that if we have 3 different states, it seems to be a very common scenario that usually every software developer will start to thinking, okay, it's a good candidate to use an enum type here. And this is a little bit misleading because enum in Java has one big disadvantage. If we have an enum type, each of the enums, the values inside this type, has exactly the same format, the same shape, has the same fields, the same potential methods, and so on and so on. And definitely modeling such completely different cases, because for approval we have amount for field, for refusal we have something like reason. This completely does not fit into the bill. So we need to look for something different. And as you can also expect, because you are probably almost of you are very experienced object-oriented programmers, you see, okay, if the enum, the pure enum does not fit the bill, we need to think about the object's hierarchy. And this is exactly the good point that probably almost of you, or even not all, would think about it. So let's go one step further. Is this exactly? And we will just start from this solution, because exactly this would be the initial step from which we will be introducing the new features of Java. And this would be a pure good solution for that one. So we have the object's hierarchy. And now it's time to step out of the slides, because honestly speaking, I do not have a lot of them, because on my sessions, I definitely prefer diving into the code. So do not, it makes no sense to hesitate more. Let's just dive into our IntelliJ. So let's go to our code base. And as you can see, we have some classes here. Let's start from the better ones, because usually, as you can expect, if there is a lot of classes, usually almost of them are very clean, neat, and nice to read. But there is always one single point of failure when all this entropy just gathers and aggregates, and exactly would be the loan up class. But let's somehow start from the better part one. So if we just start from the modeling, the input, as you can see, it's a very simple approach. We just use immutable class generated by Lombok. About immutability, I will talk a few minutes later on, because it has some common things when we're talking about records. However, just for the sake of this step, let's see, we have two fields, amount of big decimal, because modeling monetary values with double isn't a good solution, to be honest, in Java, and I do not recommend it at all. So big decimal is at least, or you can also focus on some different solutions, like for example Java Money API and so on. There is a special Java specification for that and the implementation, but let's not deep dive into it too much. And the period, okay, exactly for Java time. That's fine. Okay. As you can expect, we have the objects hierarchy. So we have three classes: refusal, approval, and suspension. And you can expect that it makes sense when all of these classes will have something in common, because you need to have the common abstraction when the evaluator processes the request and generates the response, because this is the only way in object-oriented programming to somehow model the three different cases into one pure abstraction. And as you can expect, this is just the interface. This is the response interface. It's an empty interface, because in our case, these three cases do not have anything in common as a fields or the methods. So I decided to use the interface, and this is enough for our case. However, if this common abstraction would have some logic, or there would be some common fields for all these three cases, abstract class would be probably the better solution. However, in this case, it makes no sense, so I decided to stick to the interface. That's enough. Definitely, I wouldn't recommend to have non-abstract class here, because if you just try to use non-abstract class as a hierarchy root, you risk getting into trouble, because proper inheritance in Java is a good topic for another talk, but breaking list of substitution principle, it's unfortunately too easy to be done during this process. Okay, so also evaluator is also not a very complicated class. As you can see, I just put here two rules, and just it's also for example, let's say that if we have too big amount, we just refuse the loan request. If the amount is a little bit smaller, but the period is too long, let's add the suspension. So say we need the employee reference. In other case, let's return the approval. This is also being somehow covered by the tests, as you can see, as you can finally check in the repo, because I will also provide you the link at the end of the lecture. Everything is working. The test is checking whether this evaluator works. And up till this point, everything seems to be relatively clean, nice, and neat. Okay, it's not so easy, because, as I can say, the entropy goes here. As you can see, we have the main class of our application, and the beginning of this class, it's not so bad, because we are just creating our object we are working with. This is more or less even this can be somehow modeled as a simple dependency injection framework, because we are creating all these things, and then we are just using these objects for processing the request. However, the big problem begins when we are trying to somehow handle the response, because as you can see, then if we had three different classes of our potential response, we need to somehow check which kind of response we get and react appropriately according to the spotted response type. And it isn't so nice, as you can see. This code is very hard to read, in my opinion, and it's just too verbose. And our task during the rest of 35 minutes would be to somehow make it more concise and easy to read. So, from what should we start with? The first thing that is exactly somehow burning out our eyes is this instance of. Instance of as such, it's not a big problem as such. However, usually instance of comes with the second line, which is used just after it, because if we check if our, for example, response is the type of suspension, like here, the next action we do is just casting it to this suspension. And this is very funny because, to be honest, I do not see any other option after making this test other than making this cast. Okay, there may be one. If we just say, okay, that our CPU is just too lazy or too idle, okay, we can just make some instance of without further casting, just for fun and just to make it some heat. Okay, that's fine. But to be honest, I do not see such case. So would be nice to somehow clean this mess up. And this is exactly the place when our first feature jumps in. And this is the modern instance of automatic cast introduced in about Java, as far as I know, 13. So let me somehow switch to the next version of our code. Okay. Okay. Now you can see that our code has been a little bit reduced because now we do not need to make this explicit cast because it's being included in the instance of operator. So if the test is evaluates to true, we can immediately assign the casted variable to this new variable being put in as the last part of this expression, and we can use it immediately in this code block in the if or else if. This is also another nice syntactic sugar because this instance of syntax introduces some new lexical scope, which means which is being somehow known as a instance of scope, which allows that, for example, to use this approval variable in just even not in this block, but just after the end operator, because now we can check, okay, if this approval, for example, is something like that, approval get amount. So, okay, sorry. Usually, yeah, it makes no sense. Sorry, this is a little. I just okay. Sorry, it's big decimal. Okay, that's nice. So just. Okay, now we should compile it. So, compiler is too smart enough to detect that this second part of the expression will be evaluated only if the first part evaluates to true, because this double end operator is a short circuit one. So if the first part does not evaluate to true, the second part wouldn't be even taken into account. So we can safely assume that, okay, if we just came across this one, we can say that, okay, approval is being set, this variable is okay already casted, so we can use it. As you can see, this makes the syntax a little bit more concise. Okay, maybe this is not too big step, okay, but it's always good to somehow start with even something small, but constantly improve the quality of our code, because the next thing that we will think about is, as you can say, let's go to the proprietization. This is no casting, so definitely let's forget about putting the square pegs into round holes. No, it's not needed anymore. But we can go one step further, and the next thing are records. Okay, and this is exactly the place I would like to come across once again, because I told you about this request and refusal classes. As you can see, this class request is a little bit, it's concise, because it's prepared by the Lombok. The value annotation gives us provides us that the class is immutable. All these fields are being private final. A constructor is being given here, and so on and so on. That's nice. However, using Lombok has some drawbacks, which probably we are not aware of on everyday basis, because there are, in my opinion, at least two factors that somehow makes the Lombok a little bit danger when using on everyday basis. Maybe not danger, but still is a little bit cumbersome. The first one is that now when you just when you are just waiting for the new version of JDK, you are not only you have only not to wait for the new version of JDK, but unfortunately for Lombok also. This hit me when I was just preparing some presentation based on JDK 21, because I also played with the Loom. And of course, I just waited until the JDK 21 was ready, so I just downloaded it, plugged into IntelliJ, okay, build the code, bah, does not compile. What does happen? Sorry, your Lombok will not work with new version of JDK. You will have to wait for the new release of Lombok. Ow. Okay, fortunately, it's the latency, how we can say, between introducing the new version of JDK of Lombok is being counted into days. So after 2 or 3 days, the new version of Lombok was ready, so I was able to get the new dependency, and now everything is working smoothly. However, as you can see, you are somehow locked into the vendor, because without Lombok you cannot do anything. Oi, oi. Ouch! And another thing is that Lombok causes that your code, your class file, does not really look exactly as your Java source file, because annotation processors should, and this is the rule of thumb, they should not modify existing classes. Lombok is an annotation processor, so during the compilation it generates another additional code, and the compiled code is exactly contains all the setters, getters, equals, and so on. And annotation processors should only add new classes, not modify the existing ones. As you can expect, Lombok does not stick to this rule, because if it would stick to it, it would not be a Lombok and would not work. But then you break the rule of what you see is not what you get. So another factor. Okay, one can say, nice, fine. You can just do not rely on Lombok. You can write all these getters and setters manually, and it would be fine. It's true. To be honest, the problem with these setters and getters and the equals method is not even does not even sticks in the fact that you have to write it manually, because to be honest, today almost no one writes code in the pure notepad or something like VI, and I think even for VI there are some plugins that you allow to generate automatically, and if you are using IntelliJ or something like that, this IDE will generate it for you. So it's not a problem of developers' laziness, to be honest, for just writing code. But there is another thing. Another thing is that if you even do not write, you don't even have to write this code, you have to scroll it up and down when you read this code. And unfortunately, when software developers are writing new code, it's being stated that they sacrifice about 80% of their time of reading the existing code and not writing the new one. So if you had to just wait through all this tons of code like the swamp, sorry, it's just reduces our productivity. So definitely would be nice to somehow replace the Lombok features, everything where is it possible. However, another thing is that these immutable classes are relatively a good thing, because immutable classes have big two advantages. The first one is that immutable class has the consistent state immediately after it is created, so there is no risk, for example, that you would just create your class with the new operator and leave it in inconsistent state and just hand it to another part of your code, because such behavior leads to very hard to spot bugs sometimes. So definitely immutable classes rescued from this danger. And another thing is that immutable classes are safe to use in multi-threaded environment, because even if we are just switching to the new virtual threads from JDK 21, it's still the multi-threaded environment, and all this stuff connected with contention, synchronization, and so on still applies here. So immutable classes are relatively the goodness, and we should be able to use it whenever possible. However, there is also one small trap here, and it also applies to the Lombok value, to all the classes. Your class is immutable when all of its components are immutable, because if you just prepare some class provides that all of these fields are final, and you initiate any constructor and so on, but for example one of the fields is just the mutable list, sorry, your class is not immutable, and you will face it very soon that you have some troubles. Of course there are some solutions to get rid of, but okay, this is a little bit digression. I have only 24 minutes, so let's go further. Let's somehow use the new goodness from Java 16. They are records. And as you can see, now this Lombok stuff can be just replaced with the pure Java. And the pure Java is the record. Record is being considered as a equivalent to all of these components, and this is exactly one-to-one relationship. We will talk about it a little bit later. We will be talking about records deconstruction. But as you can see, the declaration of the record is very simple. You will just say that it's the record and just enumerate all these fields. You can also leave the annotations for all the fields because some of the frameworks can rely on it, so that's fine. You are being given for free the constructor, the equals and hash code to string methods, so everything is for free, with one small exception, because this is a little bit tricky. Let's see what has changed in the loan app class. As you can see, our record has no more something like getter, because here we have something like amount, not get amount. It's being decided that when you stick to Java records, the accessor methods are no longer being called getters and do not have this prefix, which of course it's somehow breaking up with the very old convention. As far as I know, it's about Java Beans is about 20 years or more or less. So definitely when the records has been introduced, there were some troubles with some frameworks usually used, for example, for JSON serialization, deserialization like Jackson, because they were relying on the fact that the methods of the fields in class has the get or is prefix, and now it's gone. Of course, this was something like childhood disease. Now Jackson is completely mature, stable, and works with the records out of the box without any problems. And also records in Spring Boot are very nice and concise way to express configuration properties, especially the nested ones. So definitely, if you can stick to record, just use it and no worry about it. So this is another thing that I tried to present, and I think, okay, you can still be a little bit disappointed because, okay, sorry, small instance of short records, okay, but we need something more. This if, else if looks very bad, and I completely agree. Let's go to the more interesting part, pattern matching. However, this feature requires us to travel beyond Java 17, because unfortunately it's being added permanently, as far as I know, in Java 21. This is also the good reason to stay exactly with the new version, because it offers us a lot. What we need here, because as you can see, now we are just checking if this else if branches against the type of the response variable. And you can also imagine that we have the switch instruction in Java. It's very nice. However, it has severe limitations, because usually classical Java switch only allows you to check the equality of the argument against some predefined set of constant that you are just putting for each of branch of the switch. But the new version of this switch allows us to do something more and exactly to match the pattern of the type we are using here. Let's come across it. As you can see now, the situations is much more neat, because now we can, in the switch, we can use the case, the labels can be the type we would like to match our variable to the type of this labels. So now we can see, we just check whether our response is approval or refusal or suspension or default. About this default we will talk a few minutes later. Now, just don't bother about it. Let's just to cherish the joy that we have something much more concise. So we have 3 cases. It even begins to behave something like the enum, because if you were just using the enum in Java, you would exactly get something like this. You are just getting the variable and just test it against some enum values in such case, and exactly this is the final solution we are trying to get in. However, there are still some drawbacks with this switch. The first one is that we still have to use these break keywords here, unfortunately, and the break keywords in switch is a real pain in the body part. Let's not say exactly which one, because if you forget about it, it just falls through the next branch, and it also causes the very hard to spot bugs, especially in such case. It's another thing, and another is that, unfortunately, because this break, because we have this fall through, the Java compiler states that all of this switch expression under the switch is one syntax block. So, for example, you are not able to define some local variable here because it's also being visible here and here and here. So these labels, these branches are not independent on each other. And another thing is that even if we have something to do which is very concise, because it's just the one-liner like here, we still need to write it in few lines, use the break. Ouch, makes no sense. Definitely we will need something better. And now I'm trying to come back in time, because the pattern matching in switch is the construction from Java 21, but arrow labels have been introduced much more earlier, because they were permanently present in Java 17. Let's somehow go and present how does it look like. So our arrow labels allows us to write this switch like that. And now we can see arrow labels makes this syntax much more concise. Why? The first thing is that you do not need to write these ugly break statements, because each branch is now completely independent of each other. So it defines its own lexical scope. So you can even, if you want, for example, you can just introduce some local variable here. If you just have some fancy or something like that in here, of course it makes no sense here, but it's possible. So this syntax block is completely independent of this one, and so on. This is the just forget about the break. There is no reason, there is no risk that you will just jump into unexpected branch you are not, which is what wasn't on your purpose. Another thing is the fact that with the label syntax, if you have some very short one-liner here, you can just write it exactly after this arrow, and that's all. You don't even need to open the code block, because it just works out of the box. Very nice. And usually in a lot of applications, your switch construction would be very short, because such long blocks of code are not widely being present in the switch. Rather, in my case, it's a little bit further, but okay, it's still too shorter than okay. But we can go one step further. As you can see, we have this ugly if here, because we have something like approval, but our approval, to be honest, just splits up into two separate cases. The first one is just when we get the full amount here, and the second one when we are being granted the limited amount of money, so the bank lent us less money than we expected. Okay, so wouldn't it be nice to somehow write it like a separate case in Switch? Yes, it would. And in such case, let's go to something like that, guarded patterns. So guarded patterns is an extra conditions we can introduce with the on each of the switch labels, and this looks like that. Okay. Now we can see that currently we have 4 branches in our switch, and this is what exactly we were checking, we were talking about previously. The first one is just when the amount is full. If not, we are just going through another case. It works more or less. It's very clearly stated how does it work. For example, if this case is true when an additional test is being done, okay, we are going here. If not, we are just falling through the next case, and so on and so on. Also, the guarded patterns is also a very interesting thing because it clearly shows that preview features in Java can change. So you cannot take, if you are just using some preview features in some version of JDK, you cannot take it for granted. So if, for example, something was added in Java 19 as a preview feature, you cannot assume that, for example, in JDK 20, the syntax of this preview feature will be exactly the same because something has changed, and exactly was the case. Initially, these guarded patterns were being introduced without this when keyword, but with this double and operator. However, it was being stated that, okay, it's a little bit misleading, so this additional when keyword makes it more clear and what does the developer wants to express here, so we use that. Okay, fine. But still, we have very, very ugly thing here, and this is this default. Yeah. If we try to somehow hide it, this code will stop to compile. Unfortunately. Sorry. Yeah. It's very hard to... Okay, now it should work. Okay. Sorry, it's red. Why? Yeah. And this is for our safety. Because compiler says, okay, Marcin, you have this pattern matching, and okay, you have only 3 subclasses of the response currently, so probably there is no other possibility to somehow go through that your response will not fall into this, sorry, not 3 but 4 branches. But for your sake or your safety, I will protect you against it if in the future someone will add the new subclass of the response subclass, maybe the implementer of the response interface. No, and you will try to convince the compiler's buddy. I'm pretty sure that I will not give at the new implementing class. I will be safe. Sorry, your safety is on my first place. I cannot allow you for that. Ouch. Okay, so what can we do? Fortunately, the compiler isn't a blunt thing. We can negotiate with him or her, with it. And what can we do? We can try to ensure it that no class except these 3 ones will implement the response interface. And in such case, we will somehow freeze the hierarchy of our response interface of our classes. And this freezing is being called introducing it's just being sealing the class hierarchy. And is this exactly the point I would like to introduce in the next step of our session? So let's assume we would like to block the possibility to implement our response interface by different classes than our free already presents. So to just show it, let's go to this go to this response interface. Okay, and now let's change this our repository to the next step. Okay. Now, as you can see, we have clearly sealed our interface and directly enumerated all the types that can either extend it if we are talking about interfaces or implement when we are talking about classes. And there is no other possibility for any other class to implement this interface if they are not explicitly enumerated in this permits clause. The permits clause is the third clause you can use in the class interface declaration. The first two ones are very well known for you. It's extend and implements, and the permits is always the last one. So you need to explicitly enumerate all this class that you are putting here. There are some quirks about it because this class can be only in the same package or in the same module. We are talking about JDK 9 modules as in the sealed interface. However, in our case, it's not a big issue because, as you can expect, all of these classes are exactly in the same packet. Of course, this class do not have to be publicly visible because this just need to be visible within the package, but it somehow guarantees that no one else will be able to inherit after these responses. And with this, having that said, we can safely return to the loan up class. And as you can see now, we got rid of this default branch. Nice. It really begins to start to look like the enum because now we have 4 possible cases. Each of them is being enumerated in our as a switch branch, and we can just execute the proper action if we fall into given case. Okay, nice, fine. Can we go further? And the response is yes, we can. Because let's come back to the records. About 10 or 15 minutes ago, I said that a record can be treated as an equivalent of all of its components. So, for example, if our record request has 2 components, amount and period, the amount and period variables being treated as a pair or ordered components is an exact equivalent of our record. So the question is can we just directly not use this record here, but use its components directly if needed, because as you can see here, just getting this whole variable of record type makes no sense here, because immediately we are just trying to get to its components and use it in these actions within a given branch. And this is exactly the thing I would like to present you in the next step of our code. So let's see how does it look like here. Okay. And you can see that we directly are decomposing our record to its components. So we are just, these variables being here are just being populated for us when the certain branch is being executed. So we can directly use this amount or reason in this case, or these 2 fields in suspension. Of course, the one can ask questions whether this feature exactly gives us something more very big, some flexibility in that. And the question is, if the record is a flat one, so there is no nesting in it, this syntax is not so maybe not a big revolution. However, if we are just thinking about records that contains nested records and so on, this syntax opens a very broad window to write some codes very concisely, because if we, for example, we have the record and in such branch we need only one nested property, we can just use it and skip the rest of it, because using with the animate patterns and so on. So definitely it helps us to write this code more concisely. There was also another question regarding one of my talks, whether this deconstruction is mandatory. Of course it's not. If it's much more convenient to you to use just the whole record, you can still use it. There is no obligation to just use these components in these switch cases. Okay. Another thing is that the name of the components can be completely random, because the recognition of the fields in the record is being used by the order. So if I, for example, name it XXX, it still be the additional requirements field from the record. I'm just trying to use this name to be somehow concise and self-descriptive, because we are just consistent when naming all these parts. That's fine, okay. However, you can just use it with your name as you want. Okay, 3 minutes. Okay, let's somehow try to conclude this. So as I wrap it up, we just transformed our code to use to even if we had the object hierarchy now can be treated as an enums with our switch. Can be read very concisely. Let's use also this Java goodness. So also we can get at least some portion of Lombok. And the code, in my opinion, is much more readable as it was at the beginning, and without losing the flexibility of our classes, because as you can see, still they are a little bit different. They still carry different data, and they are clear to read. Okay, if anyone is eager to play with this code, you can just take my repository. Okay. So I invite you to do that. Okay, that's 1 minute. Okay. If someone is interested in contacting with me, there's also QR code to my website when there are my contact data to me. So if you have some questions regarding this talk or different things, just drop me an email or notify me on GitHub. There are also other repositories. And if we are ready, I think there is even 2 minutes for potential questions. Okay, are there any? Okay. If not, I wish you a very good evening and a lot of exciting talks and sessions during the next 2 days of the conference. Thank you.